The presentation that we're doing is called hash tables, hashing with chaining. So what are hash tables? Hash table is a data structure that maps key value lookups, and it's usually in a array format structure. The primary functions to understand are hashing, avoiding collisions, and inputting key value pairs. So what is hashing? It's usually a function that computes by taking in a string and converting it into an integer. And after it gets an integer, it maps that to the location of the table. So by doing this, we're able to look up for our data at O of 1. So we map from the key and then to the hash code, then over to the index. So the image on the right, let's say that we are trying to add Lisa Smith into the hash table, and Lisa Smith will go through the hash function. So in this case, it'll return the integer value of 1. So Lisa will be placed in the index 1 in the table, and this process gets continued for the other keys as well. So Sam Doe, the third key, is being placed in 4 because once it went to the hash function, it returned the integer of 4. And when this is being processed, one thing to avoid is collision. And collision is basically creating a duplicated location spot for that data storage. So let's say, for example, Michael is already placed in index 2, and we want to add Toby, but once Toby goes to the hash function, it returned a integer value of 2 as well. And since 2 is already taken by Michael, this is what a collision is. And there are a couple ways to avoid collision, and one way is called chaining. Chaining basically avoids the collision, and all key value pairs mapping to the same index location gets stored as a linked list. So for example, here on the image, let's say that Jack Williams is already placed in this location here, and we want to place Andrew Wilson, highlighted red as well. And since Andrew Wilson's location is already taken, what chaining does is that it creates a linked list on that particular location. So if you want, so once Andrew gets added, let's say we want to add a person named Bob, and Bob's hash function returns the same location number of the table. So Bob is going to be placed right next to Andrew Wilson, Andrew Wilson's node. The complexity of the hash table for worst case will be a O of n. So on the image here, let's say that all the locations are filled, and each location has a linked list of 100 nodes. And if the name that we want is in the last node of any of the linked list here, then it's going to take that many names to go through to find that. So that's why it's going to be of O of n for worst case. And the expected case, if each index has at least one chain, so one linked list, it's going to be also of O of n because how many names there are is the amount we have to go through, and the average we want is O of 1 with no chaining. One of the advantages of the hash table is that it's a lot more simple to implement, and table never fills up, so we can always add more elements to the chain. It's also less sensitive to the hash function or the load factor, and it's mostly used when it's unknown about how many and how frequently keys may be inserted or deleted. And for weaknesses, it can be a wastage of space. Like some parts of the hash table are never used. And also, if the chain becomes very long, then the search time will be the worst case, will be O of n. And there's also a lot of uses for extra space for the links. So the pseudocode for insert will be expecting a key and a value, and the hash is going to be the location of where it's going to be placed. So basically, in the if stem, it's checking the location and if a node exists, and if it does exist, then we want to place it next to that current node that's next to the current node. And if there is no current node in the location, then we are just going to add a new node. Next one is the find method. So the hash here again is the basically the location where it should be placed. So the while loop here is checking if the current node in the index exists, and then if it does, it's gonna traverse through it, and if we do find it, if we do find it, then we're gonna return that node. And if there's nothing, and if it doesn't exist there, then it'll just return a string of nothing found. So let's say that we're trying to look for Rob. It's going to search for that current location, and then return it. So for the removing node, the remove method, again, the hash is going to be the location of where it's going to be placed. So the while loop here is checking that while a value does exist there, and if the location is the same with that first node, then we're going to remove it. And then here we're checking that if the node already does exist, then we're going to be continuing the search, and then we're going to remove it. So here we're trying to remove Emma. And then it finds the location. And then it's going to be traversing through, since there is already a current node there. And then once it finds it, it removes it.
Thank you, Richard. So this is Edmund, and I'll be going through the code portion of HashTable's chaining when a collision happens in particular. So this is our application on the left here. This is our console window on the top right. And on the bottom right here, I'll just be trying to explain what's happening in the code. And I'll be drawing some diagrams to try to explain what's happening. So just looking at our code here, try to ignore the console.write lines. They're just for the console. First of all, we have the data here. For our data, we're going to be talking about footwear, shoes, trainers, and you can see here we've got a key value and some string data. The key value, I just decided to base the key value on the price of these sneakers, trainers, made up prices. So let me just go down. So that's my data here. First of all, I have a class. It's called OpenTable, and this essentially makes all the nodes that we have for our table. So each node will have a key value, the data as a string, and a pointer to the next node. We've got a constructor here that creates it, methods that get the key, get the data, set the next node, and get the next node. Within that open table class, we also have a hash node table. The constant size in our algorithm is always going to be 10. So that's just for our application. And then we have a method here that helps us produce that table of 10 hash buckets, so to speak. And then following on from that, this is the actual code we will go through that helps us insert a node to the hash table, find a node in the hash table, and remove one as well. So without further ado, let's go through the code. So in the top right, we're going to be putting in the first piece of data, which is a Nike pair of trainers at $40. So I'm going to hit return. So what happens in the code is it creates the node. So maybe I should write here. I'm just going to put Nike. I'm just going to put it in, and then I'm going to put 40. So in our code, what happens is, first of all, you have to make a hash. The hash refers to the table. Let me actually produce the table quickly here. So this is our table that gets created, as I mentioned, from here. Only happens once, so this is just a visualization of it. And this is our table. And how nodes are put in is we have to create a hash which will become the location at which we store the new nodes that we make. So we made the Nike trainers at $40 here. That's the first one that we made. And then we have to decide where is it going to be located in this bucket. The key in our case is 40. And the way we calculate the hash is always going to be the same. You take the key and then you mod it by the size, and the result of that will be the hash. So in our case, 40 mod 10, there's no remainder. So our hash value is going to be 0. And this is going to happen all the time now. If you have a pair of trainers, which is like $30, 30, which will be the key, mod size. So 30 mod 10, again, equals 0, which will be the hash 0. So just a quick example. So just to carry on in our code, our example is we're going to use the hash at 0, which will be there. And then what happens in our code is, for the insert code is, first of all, we check, we do a quick check here just to make sure that what we are putting in, we have to make sure it matches the hash location that we're trying to put it in. And in the rare instance where it doesn't, this bit of code creates a new hash. So just quickly explain this one. While the current hash table is not null, in our case, it is null, so this will fail. The key in the current hash location mod the size, so that hash value is not equal to the hash value that you're trying to add in. Remember, the hash is calculated by the key mod size. So in the rare instance that is the case, then we change the hash. We increase the hash by 1 and then mod that size to create a different hash. But in this case, because this is null and the hash location is 0, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We bypass the while loop and we go to the first if statement. The first if statement in the insert method always checks to see if the hash location that you're trying to put the node in, is it empty? Is it not empty? And just to make sure that the hash that you calculated is exactly equal to the hash location that you're trying to put your new node, our Nike trainers, into. In our case, this is empty, so we're going to ignore this bit of code, and this is just simply, ignore the code at the top, this is just simply, we're going to put the new object here, n object is the new object, which is this one. We're going to put that one into the table hash location that we have because it's empty. So we don't need to do much else, and then we return. This just to show it happening in the code. There we go. It sees that it was empty here. Hash location 0 is empty, so we're going to put in the Nike trainers at $40, and that's simply the first one that we put in, a very simple node that we put in, and then we go right to the top. Let me just clear this out, and we go and look at the second piece of data, which is Adidas. So I'm going to put I'm going to put $30 here. The key is 30. So again, have a think. We're going to calculate the hash, which is key mod size, which is 30 mod 10. And if you think about that one's going to be equal to 0. And so, again, this is the insert code. We're going to calculate the hash, which is 0 at the moment. And then while the current table hash 0 is not null, which in this case it is not null. So this one passes, that passes, and we're going to check this, right? Is the hash, right, is the key mod size, so the current key here is 40, because it's hash table hash, which is 0 dot get key, which is to get this key, and then mod, so 40 mod the size is still 0. Is that not equal to the current key, which is 30, mod that size, which is also 0? So are they not the same? They are the same, so this while loop fails. Again, this is just the catch in the case where the key mod size of the current hash table that you're looking in is not equal to the key mod size, the hash value that you are trying to put in the new node. So we bypass the while loop and we go to the if statement here. If the table hash, which is at 0 here, so again here, again, currently there's Nike at $40. We're trying to put the Adidas of $30. Is the current table's hash at 0 not equal to null? It's not equal to null, so that passes. That's good. Is the hash, which is 0, exactly equal to get the key of the current node in this hash, which is 40, mod it by the size, which is 10. So 40 mod 10 is equal to 0. So this does pass. So we are going to run this bit of code here, specifically here. So if we have a look at here, so what happens now is, because there is already Nike trainers at $40, this one doesn't point to anything at the moment. So, okay, so back to the code. So this is the, if we're looking at hash 0, currently there's Nike at $40 here. Nike at $30. We're trying to add this to the hash location. This is where our collision occurs because there's already a value, a hash of 0. So first when you do line 108, we're going to set the new node that we're going to point in, set the next node to be whatever the current node in the current hash table is at location 0, whatever that's pointing to next, we're going to point the new node where that's pointing to. So currently the Nike trainers are pointing to an empty space at the moment. So what we're going to say is, right, you're not going to do that. You're going to point to the next empty space here. And then we run the next bit of code here, 109, where we're going to say, okay, so in that case, if the new node is going to point to whatever the current node, the Nike trainers were pointing to, then we're going to say that the node table at hash 0, your pointer is now going to be pointing to the next node, the new node that we're going to put in. And that's how we enter in a node and avoid collision. So we point the existing node in the hash table to the new node. And so what we should see here is this is a hash location 0. The Nike trainers at $40 should be pointing to the Adidas at $30. And let me just hit return. Hit return one more time. And yep, there we go. That's how we avoid the collision and insert the node there. Okay, this is a good final example to go through. If we look at this, we're going to be putting in a pair of Adidas at $59 or $59 for the key. 59 mod 10 it leaves us with 9. So we're going to be putting it here. So this is a good example of another collision. So just to draw this out, we have some vans here, and that's pointing to some Timberlands, which is pointing to like nothing really. So that's just where it's pointing to next. And these will be the Adidas. Without pressing the console, we're just going to have a look at the code right here. Again, calculate the hash. So our hash is 9. Run this check. No matter how we look at the keys, 49 mod 10 is 9. 99 mod 10 is 9. So when we look at this bit of code, we've gone through a few times. This is just basically trying to check if the hash is exactly equal to, it's not equal to the hash value when we try and get the key from the table, and it's not equal to that. So we run this bit of code because yes, the current hash table is not null. There are 2 trainers in there, 2 pairs of shoes. And the hash value that we have of 9 is exactly equal to the, when we try and get the key from here, 49 mod size is equal to 9. So we are going to run this bit of code. So what happens is it takes the new node, which is the Adidas. Okay, you're going to be pointing to whatever the current hash node is pointing to next, which is this one. So which is the Vans. So now we're going to say, right, you're going to be pointing to the Timberlands. And then we're going to say, right, the current hash tables node is going to be pointing to the Adidas. So this time, this one is going to be pointing like this. So what we end up with is we're going to have, at hash location 9, we're going to have the Vans, which points to the Adidas, which points to the Timberlands. And there we go, the Vans, the Adidas, and the Timberlands. And that's mostly about the insert methods. We're going to be talking about the find method next. So here we have the find method. Okay, so this time I'm going to do things a bit differently for the find method. I'm just going to display the whole table as how we have it now if we added in all the values. So you can see we've added in shoes for the hash bucket location of 0, 1, 2, 5, and 7, and 9. Some of these have 1 pair of shoes. Some of these hash buckets have multiple pairs of shoes. So with the find method, if we go through things quickly, all it is you just need to pass in the key. So let's say we're going to be looking for the key of 55. Again, calculate the hash. So first of all, we're going to calculate the hash. So 55 mod 10 is 5. Once we've done that, again, we do the while loop check as well, just to make sure that the hash type value of the current node, if it's not empty, this is not empty here. If that value is not equal to the hash value that we created, we increase the hash by 1. In this case, if we look at the 45, 45 mod 10 is still 5, so that's fine. So we're going to ignore this bit. And once we've done that, we create a hash node called current, just to hold the current node that we're looking in the hash bucket. So in our case, we're going to be placing the Vans at $45. Let me just call this current here. So just tidy things up as well, actually make things a little easier. So now at line 161, we're going to add in the current node that we're looking at in the bucket when we go through it. So the current one is the Vans. And now whilst we get the key in the current node, which is 45, whilst that key is not equal to the current key, which is not 55, so this passes, and then we also check if the current node, whatever it points to next, is what it points to next not null. Our Vans, we know it points to the Vans here at $55, so it's not null. So this whole while loop passes, so that means we've checked this current node and we know that that's not the node that we're looking for. So we set the current node to be the current dot get this one. So now the current node now is the vans at 55, and we know that the vans at 55 points to nothing, but we just mentioned the next pointer here. And then we break out of this while loop, and this would keep going on and on and on until because we check each if statement to check, right, is this current node get the key equal to the key that we want? In our case, just so happens to be exactly the right key. So this passes, and then we return the key that we found. So yeah, so let's imagine we're going to try and find the address of $30. Again, create hash. So 30 mod 10 is equal to 0. So this is 0 now. Oops, 0. So again, whilst the table is not null, which is not null here, table 0, hash table 0, whilst the node and get the key, which is 40, mod the size, so 40 mod 10 is still 0. Is that not equal to the current hash value? They are exactly identical, so we're going to ignore this. Set the current node to be the node in the hash table at location 0. So our current node is going to be the Nike at $40, but I'm just actually, yeah. So I'm going to put N at 40, and then whilst the current node get the key, which is 40 here, is not equal to our key. They are not the same, so 40 is not equal to 30, and the current node's next node is not null. We have a look, Nike at $40, the next node is the Timberlands at 120, so we know that's not null, so this code does run. We're going to be setting the current node to be whatever the current node's next node is. So now this would be the Timberlands at 120, and just for our sake, I'm just going to put the address of $30 here. Okay, this while loop, we don't break out of it, so we just continue. So we come back to the while loop again at the top. Again, we check the current key, get key, which is 120. Is that not equal to the current key, which is true? It's not equal to that. And the current dot get next node is not equal to null. That's not equal to null. So Timberland's next node is empty. That's not equal to null. So we set the current to be the current node, the next node here, which is the Adidas. So again, we take that A. So the current node now is the Adidas. And we know from our table that the Adidas doesn't point to anything. At this point, we go back to the while loop. Is the current key, the get key, not equal to the current key? So the current key is 30. The key that we're looking for is 30. So this actually doesn't pass. So we break out of the while loop. And then we go to the first if statement where we check if the current key is exactly equal to the key, which it is. And then that's where we could run this get data. In the event that we reach the end and we've checked all the nodes and we don't find the key, then we do return nothing was found. Okay, we're going to go through the remove method using the same table as we're showing up here. So again, first of all, let's say we want to remove the here Nike at $41 at hash table 1. So $41 hash table 1. So calculate the hash. In our case, the hash is going to be 41 mod 10, which leaves us with 1. And then we go through the while loop again. Check if the current hash table that we're looking at 1 is not equal to null, which is not equal to null. Yes, there is a value in there. And then we check if that key mod the size, which is 1, is not equal to the current hash value that we have, which is 1 here. Again, key mod size always refers to the hash. They are exactly identical, so this while loop does not pass. We then set the current node, this variable current, to be the node of the hash table. So we're going to say Nike at $41. And then bool is removed is false. And then we're going to say, right, whilst the current node is not null, we run this bit of code here and check if the key that we're looking at in the current node is exactly the key that we're looking for here. In our case, it is. We do find a match. So what happens now is we set the current hash table. So we're going to set this hash table now, which is, remember, that one's the Nike at $41. We're going to set that to whatever the current node is pointing to next. In our case, it's pointing to nothing. So, you know, there's like no here, or it's just basically pointing to nothing. So here is here, they're exactly the same. And then we say is removed is true. So we set the bool is removed to true. And that's it, we break out to the node. So now what will that do is that will set this Nike 41s to nothing, and that helps us remove the node here. Let's say we want to remove the Vans at $45 here. So the key is 45. So key is 45. Calculate the hash. So 45 mod 10 is 5. Whilst the current hash location at 5 is not null, which is not null, but we do see that each of these hash values, 45 mod 10, 55 mod 10, they are not equal to, they are equal to the current hash, so this does not pass. Set the current node to be the hash node here, which is Vans at 45. And I will add the Vans at 55 here as the next pointer is pointing to. And this one basically points to nothing, as we can see from here. So first of all, we check current Boolean is removed as false. So this is false for the time being. And then we say, right, is the current node not equal to null? It is not equal to null. So we run this bit of code here. And then we say, right, the current node get key is 45. Is that exactly equal to the current key that we're looking for? It is. So now we're going to say, right, okay, so in that case, the node here at the table hash of 5, you're going to be equal to whatever the current key is, because we know the current key is the one that we want to remove, but we're going to set this one to be the next node. So this is, remember, hash table 5, but we're going to say, right, you're going to be now equal to 55. That effectively breaks that link here, and that would get rid of the current, and that would get rid of the Vans at $45. And the first node, when we look at bucket 5, will be the Vans at 55 here. Let's say we're trying to get rid of 55 instead. What would happen is when we get to here and we look at the current node, if we were doing the same bit of code in the same bucket, if we look at the current node and we get its key, we know that 45 is not equal to 55. So we ignore this bit of code and we go to the next bit of code where we check to make sure that the next node is not null. Otherwise, you know, there will be nothing to delete and we bypass this bit of code because we would have already checked everything here. We see it's not null. So then we see if the current, get the next node, which is this one here, the Vans at $55, and get that key and check that with the current key. In our case, this passes. So we are going to run this bit of code. If it didn't pass, we would keep moving on to the next node where we set the current node to be the next node of the current. But because this passes, we're going to take, we're going to create a new variable called new node, new holder, and we're going to set this one to whatever the current is, what the next node of that next node is. So whatever the current is, next node, next node. So actually this new next actually basically points to nothing here. Well, that's what it equates to. Set the current node, this one, next node, which is this one, to be this new node, which points to nothing. And by doing that, we then say that we have removed the node, and therefore we have removed the Vans at $55 because we're pointing this current node, which is of the Vans at $45, now points to nothing because that one's been removed. And that Boolean statement is always checked here, because if it ever turns out to be false, we know that nothing can be removed. And that's a quick run through of the hash tables for the insert, find, and remove methods. So yes, thank you for watching our video. These are the references that we used in order to go through our code. And thank you for your time.